Hi, in this video we're going to make a quick lathe part with a groove and a part off. Now you want to make sure you're in design and select the create sketch tab and select this plane here. And I kind of do the lathe part with half the part because I want to revolve it, and I'll show you right now. Start on 0, we'll come up about that far. Kind of want to just do the a sketch of sort of the shape of the part you're making, then you can add dimensions later. So we'll do a diameter here, groove there, back up to the same diameter there. That line's not perpendicular, but we'll fix that. We'll go up that far, back a little, and then we'll highlight or put the cursor over the starting point so we get a blue hash line all the way down to 0, and then we'll connect it to our starting point. If it's all blue, that means that all of our geometry is connected. Now's a good time to go in here and make certain lines perpendicular that you didn't get straight, these two. And make sure our 0 line is perpendicular to the back as well. Okay, that looks good. Now I select a dimension sketch in the top left, and I start at 0, left click it, then left click on one of your first lines. We're making dimensions, and let's say we want to make that a 1-inch dimension. We're going to make that 500. Okay, now we're going to make our O-ring diameter 400. Okay, this other dimension behind it is going to be the same as our 500, so you can highlight both of them, and instead of typing in a number, you can just make it reference your other dimension, and it'll say D1 as your dimension 1. So now if I change the front dimension to 625, the back one changes as well. It's reference to that other dimension. Now let's do our major dimension, and let's make it 1 inch, which will be 2 inches. Now I like to do my diameters first, make sure they look okay. Then I like to do the overall length, and let's make this one 2 inches long. It doesn't matter that that's shorter than our previous geometry. You can hit escape to get off of the dimension tab, and you can drag your dimensions until they have dimensions with them that are, well, you can drag your geometry around until it has a dimension with it. So if it looked weird like I just did, I just drug it around. So our overall length is 2 inches. Let's go here, press escape again, so we're not selecting anything. Let's go to 0 to the front of our O-ring. Let's make that 500 thousandths. Let's make our O-ring width 187 or 3/16. All right, now let's make this 1 inch or 2 inch diameter. Let's make that 1 inch long. Okay, so now we have some sort of part with a bunch of dimensions on it. I want to make the relationship between the O-ring and the major diameter a little bit better than that. So let's double click on that. We'll take the 625 and we'll minus it 187 so that the O-ring is square. or the O-ring groove is square. Now, if we change it, it'll remain square. Now let's do this also. 500. Stay square, see? Let's go back to 625. It's always pretty good to have dimensions that are in relationship to others. That way, one changes, the other one changes. It can be a pain sometimes if something changes that you don't want to change, but with a little bit of attention, it'll be all right. So now we have dimensions on geometry. You want to go to solid on the upper left, then scroll to the third one is revolve. Now geometry is going to highlight, and it's going to ask us, this little window that pops up, which axis are we going to revolve on? We want this one here, which gives us a solid that is revolved around our center line 360 degrees, and it'll be a new body. Now you can scroll around and see how it looks. Here's where I like to add any chamfers or radii. So I just do a chamfer, pop up. Then I highlight all the dimensions I want chamfered. This one, or all the corners I want chamfered, excuse me. All of those OD dimensions, OD diameters get chamfered 10 thousandths. Do a radius. I want the inside of my O-ring groove to be 10 thousandths radius. There you go, 10 thousandths. That looks nice, and we'll put a 15 thousandths on this intersect right here. It's already highlighted. 15 thousandths is going to be there. If you're using a 15 thousandths radius insert, it'll automatically be there, but I like to put one in there anyway. There's our simple part. Now I have tools that are already loaded in my tutorials or in my templates, and I'll show you what they are. Go to design, drop down, go to manufacture. Okay. The Fusion 360 will switch to machining. Right click on setups, click new setup, and it automatically goes to turning or mill turn. Make sure you have it selected. I like to put flip Z axis. Sometimes it's not flipped. That's good. Everything else is good. X axis, it's already there. I just highlight it anyway, just to make sure it's on. Save planes, 100 thousandths, 400 from the back, that's fine. Stock. This says 2 inches length. You know we're not working with 2 inches if you're on a lathe. It's usually a 1/4 inch longer. I don't want it from center because then Fusion is going to think that it's machining an 1/8 inch off the front. I only need a couple passes. I only need a couple passes on there. So we'll put offset from the front. That's what I like. Let's do an OD that's a little bit bigger. Let's say we couldn't find 2 inch material, so we got to do 2 1/4. All right. Post process, we won't really worry about that. We'll just change it to program 1. Hit OK. Now, all of my tools are saved in templates, so I right click, create from template. Some of the stuff is already here that I've been using recently, but I always select template on the bottom, and all of my tools are in the cloud. Scroll down and go to OD facing. This is a CNMG that faces to 0. I didn't put it in. Okay, let's try that again. So that template, OD facing, select. Now I'll put it in. This template, I made it face down and give me 2 passes. It's pretty easy, basic. The only thing I want to change is that 90 degrees right there. That looks good. When I saved this template, I saved it with a manual NC. My manual NC is force tool change. I want my guys to physically look at the face and make sure that it's 100% cleaned up. That's something that some maybe new operators are just missing sometimes. I want them to physically look at it, blow it off with the air hose, and say the face is clean. Right click, setup again, go to template, select template. I use another OD tool, and it is OD roughing. And it pops up. My templates are set up to where the front is the model front, the back is the model back, and the 2.5 inch offset is the stock length. So it's already all set up for me. You can set yours up how you like it. It's important to have it saved in template so that you're not wasting time programming from scratch every single time. You'll do it the first time, and if you do it right, or you want to mod it later, you can save over the top of the other one you had. But always improving is better. My profiles are saved here. The only thing that isn't on there, it's actually on this one. On my finisher, the minor diameter is not selected, but on the rougher it is. So we have that. Cycle and directions already saved. This is all standard stuff. No grooving. Use a can cycle. Max depth 70 thousandths. That's kind of just a standard. Leave stock 20 thousandths. 20 thousandths for steel, carbon steel. Less for stainless. 10 thousandths for stainless. Z stock, I like to leave 3 on the face because I don't. Every time I machine, I drag the tool up a face, not down it, unless I need to change something else or use a photographic finish. You might have seen a photographic finish on one of my templates right here. That's like this right here. That is for a flange that has a gasket. It's a fast face feed. I'm not using that right now. That one does go down on the face. Okay, we roughed it out. Go back to the templates. Name your tools, what they are, so your operators know what you're looking for. VNMG 331 OD finishing. Select. Even though it's selected, I still edit it a little bit. It doesn't know where the back is on this one. Sometimes I don't want to face all the way to where the rougher did. I'll select the back face, go 50 thousandths past. There's no point in turning something that is going to get part off. There's no need in machining that. So that's done. The clearance is not set on this one because sometimes I only want to face or turn certain diameters. On my VNMG, my finisher, I come in here and I tell it everything else. For the most part, it's still faster than doing it from scratch. That's the major OD, the clearance. Outer radius is going to be this one. Inner radius is going to be right below that minor OD on the chamfer. Now, on my roughing face, that faces to 0. That way my finisher doesn't have to face that dimension. Everything is set from there. My finisher, if I have links that are a certain length, the OD finisher should be set to that. You can adjust that instead of facing too much here or facing too much there. It'll be set proper. So now I have all my dimensions set. My cycles and direction are normal, front to back. No grooving involved in this one. One step, one pass. We don't need to have a spring press I don't have sharp corners on. I want that tool to stay in contact with the corner as it rolls around. It's easier to sand or deburr. No dragging involved. It's going to drag up the face. If you have it disabled, no dragging means it's going to face downwards with the way the tool is facing. This tool is facing down like that, like on your lathe, on a CNC lathe. Feed rate, maybe it's a little fast depending on what you want. 6 thou, pretty much the norm. 8 if you have a 62 finish or 125 finish. Easy. Again, that's something that's on the print. It changes on every print. There's no need in providing a 32 finish when the customer clearly states that 125 is okay. Here, linking, safe distance 80. That's just norm defaults. Linear lead in 20 thousandths. There's no need in starting out 100 thousandths off the face. Lead out, same as lead in. Press OK. There's our path. Starts down here. Goes across this O-ring groove. Doesn't machine the groove. You don't want to bury that tool. That's why that tab was not selected. So let's go to setup and watch a simulation. Let's turn off the model so all we see is the stock. Facing. Turn to OD. Finish the OD. Complete. Now you see my tool 1 was a DNMG on the simulation. I have it saved like that just so I can see it, but the description is CNMG. That's pretty typical, for me at least. Let's turn the model back on. Now let's go to the groove I have saved. Right click on the setup again, select template, and I like to use a 125 part off, and it's like an ISCAR with a it can double as a part off or a groover. I select that. Now it doesn't know where it wants to machine at yet. This is saved, the tool is saved pretty much for designing the tool, the holder, the speeds and feeds. What it does, what it's machining, it doesn't know. It's not saved because everyone's different. That's why I have to select all of these. This is my clearance, it's 100 thousandths. I retract, same dimension, 50 thousandths. Outer radius, same dimension, same diameter. The inner, it says diameter there. I like to select selection. And then I select the minor diameter of the groove. Okay. Let's go back one. Where is this groove at? It's asking you. I go to selection and I select the front of the groove. You can see starting to put some tool paths on there. Now let's go to, oh, that says part off. That's not what we want. Let's clear that. That's the wrong tool. Right click, template, okay, let's clear that. Okay, let's take this. We'll create a derived operation. Yep. Okay, let's take that part off tool and create a derived operation. Turning, groove roughing. And it's going to go below our part off tool, but we can move it around. Okay, so where is this groove at? I'm going to put selection, front of the groove, back of the selection, back of the chamfer. Alright, so it knows the front and the back of the groove. Clearance is going to be that diameter. Outer radius, same diameter. Inner radius is going to be selection right there. And then we can leave the rest alone. It should all be set. We can leave some stock there. And press OK. And we'll get some cuts here. That's alright. I don't like that 145-degree retract, so I'll take it out. Relief distance 0. Alright, that's better. Let's take that same operation and take it and make a groove finishing. Okay, all the other stuff that's selected will be on there. It's already selected. The only thing I don't want is I don't want sharp corners. And I leave that selected there. Let's take that. Another thing we're looking for is avoid upward cutting. On a groover, I don't want to go up the face. I want it to do one side then the other. Press OK. There you go. That's that. Let's go back to the rougher and tell it that it can change. Our step over can be 100. That's better. Let's regenerate the second one. Yes. All right. Now let's move our part off. Same tool. Move it below. And a good thing here is to add another force tool change so your operators have a chance to measure that groove before it parts off. So let's right click the force tool change and duplicate it. And then we can drag it right in front of the part off operation. Let's edit the part off operation. It was none of that other stuff that we selected. Our clearance is going to be up here, major diameter. The retract is going to be above the major diameter. 150. Outer radius is going to be the same, major diameter. The inner radius, now here's the thing, if you don't have a parts catcher, you can machine to 100 thousandths or 125. Your part will stay attached. All your operator has to do is just go in there, twist it a little bit, take it out, run another one. So I leave that at 125. Now on geometry, I want an edge break 10 thousandths. Take it off, and our little chamfer tool path goes away right here. Turn it back on. It comes back. Now it'll feed down to just below that. Come up, go over to the right, and start a little chamfer, and then feed down the rest of the way. This can also be a fillet. If you want a 10 thousandths fillet with the same tool, it's important to describe the tool you're using. If you're using a part off tool with a 25 thousandths radius, tell it. The tool path will be different. It's important to be specific when you have certain tools in there with different radii. Alright, so that's that. We have that chamfer and edge break done, 45 degrees. Press OK. Now you can see leftover stock right here. That's what I'm talking about. When you part that off, if you want to just drop it, fine. Throw it out the machine, that's great. Or you can do something totally different. You can machine to 0, but you can manually edit your program. And when it gets to 100 diameter, go in there and put a G97 S125 and let it feed slowly to where the part just drops off at a speed, an RPM of 125 instead of 2000 or something. It'll fall into shavings, they'll cushion it. You have a decent part. You don't have to go in there and throw a part across the machine or break a glass or anything like that. That is easy. All of that will give us this simulation. Turn the model off real quick. That's it. I hope that was helpful to any of you. If you liked it, like and subscribe. Have a good night.